So now we will focus on application part. So first application is we have to see solution of linear system of equations. Linear system of equations. And we will see existence and uniqueness of the solution. So if linear system of equations are given, whether solution exists or it has unique solution or it has infinitely many solution. So that we will study in linear system of equations. So consider a linear system of m equations in n unknowns. N unknowns x1, x2 and xn. This is xn. And that is of the form so this is of the form a11 x1, a12 x2, a1n xn, b1. Then we have a21 x1, a22 x2, a2 and xn, and this is b2. This is am1 x1, and this will be bm. So this is linear system of m equations and there are n unknowns. So this is called linear because all xj's have power 1. All xj j1 to n powers are 1. So it's a linear system. j1 to n, x1, x2, xn. Now, if all bj is 0, if all bj means 1 to m, if all bj's are 0, then it's a homogeneous linear system. It's a homogeneous linear system. If at least one bj is not 0, is not 0. Is not 0, then it's a non-homogeneous system. Now, this A11, A12 and so on are numbers called coefficient of the system. We call it as coefficient of the system. This B1, B2 are also numbers. Are also numbers. Now, here x1, x2, xn are numbers that are solution of equation 1. x1, x2, xn are solution of equation 1 that satisfies all m equations. That is the meaning of solution. If x1, x2, xn are solution, they will satisfy these m equations. Now, we will write in terms of matrix notation, we will write the solution vector of equation 1 is a vector x, whose component form its solution. Now, this all solution can be represented in vector form in a column vector x whose components are x1, x2, xn. Okay. Now, we will write this equation in matrix notation. We can write 1 as matrix A x is equal to B. In matrix notation, we can write equation 1 in this form, where A is called as the coefficient matrix. So, this is A11, A12 and so on, A1n. This is A21 and so on, AM1, AM2 and AM. This is called the coefficient matrix. This is the coefficient matrix, where X is a vector whose solution is, let's say, x1, x2 and xn, and B is also a column vector. This will be B1, B2 and Bm. So you can easily verify Ax is equal to B. So this equation 1 can be written in this form. Now we want to determine system 1 completely, means we have to check its existence and uniqueness of the solution. So to determine system 1 completely, we will write augmented matrix. Augmented matrix. So by writing augmented matrix, we can determine system 1 completely. It means we have to check whether solution exists or not. If it exists, whether it is unique solution or infinitely many solution. So how to write the augmented matrix? We will first write the coefficients A112, A1n, and then we will write here, this is the coefficient matrix AMN, and then in this we will write this dotted line, and here we will write the numbers B1, then you have B2 and so on. Here you have B. So this is the augmented matrix. Augmented matrix contains all the numbers, coefficient of the system and number B1 to Bm. And you will see, by working on the augmented matrix, we can determine the system completely. Clear? Now here, because there are m equation n unknowns, so in equation 1, if m is greater than n, means number of equation is more than the number of unknown. So we say that system is overdetermined. System is overdetermined. If m is equal to n, we say that system is determined. Determined. If m is less than n, we say system is underdetermined. Underdetermined. And if equation 1 has at least one solution, at least one solution, it is called consistent. It is called consistent. System 1 is called consistent if it has at least one solution. If no solution, it is called inconsistent. Okay? What is linear system of equation? And we have introduced the different terms. Okay? So now we have to find, if linear system of equation is given, how to check their existence and uniqueness of the solution. So we will use here Gauss elimination, and back substitution method. And back substitution Gauss elimination and back substitution method. And we will apply elementary row operation on augmented matrix. Elementary row operations on augmented matrix. ठीक है? Elementary row operation on augmented matrix. For example, let's take one example. Equation is x1 minus x2 plus x3 is 0. Then you have minus x1 plus x2 minus x3 is 0. Then you have 10x2 plus 25x3, that will be 90, and then you have 20x1 plus 10x2, and that is it. This is the linear system of equation. There are 4 equations and there are 3 unknowns. And we have to check their existence and uniqueness of the solution. Whether solution exists, or it has unique solution, or it has infinitely many solutions. So what we will do, we will first write the augmented matrix. So in augmented matrix, you will get this is 1, this is minus 1, and this is 1 here. And on this side you have 0. Then you have again minus 1, plus 1, minus 1, 0. Then you have 0, you have a 10, 25, 90. Here you have a 20, 10, 0 and 80. ठीक है? Now, what is elementary row operation? If I am writing it as elementary row operation. So it's like interchange of 2 rows. Interchange of rows, will not interchange of rows. We can interchange these rows because that will not change the solution. You can write any equation as the first equation or last equation.
So that's why that is interchange of rows is allowed. Now we have addition of constant multiple of one row to another row. Addition of constant multiple of one row to another row. Means you can multiply any row with some constant and then you can add, that will not change the solution. And third is multiplication of a row with non-zero constant. So we can multiply any row with some non-zero constant because that will not change the solution. So that is the elementary row operation. ठीक है? So let's see by applying this elementary row operation how we will get the solution. So we will use Gauss elimination and back substitution. So first we have to consider this row as a pivot row and this element as a pivot element. This is the pivot row and this is pivot element. And by seeing this pivot element, we have to eliminate x1 from these equations. These are the coefficient of x1. So we want to eliminate this. First you want to eliminate this. Then you will see second row as a pivot element. Then again we will eliminate x2 and so on. Okay? So let's see if this is the pivot element and you want to eliminate this. So you will get here, first row is written as 1, minus 1, 1 and 0 and this is second row. So second row is R2 plus R1. If you add this row with first row, that is elementary row operation, this is 0, this is 0, this is 0, this is 0. This remains same because this is already 0. So that will be 0, 10, 25, 90. Now you want to eliminate this. So that will be what? R4 minus 20 R1. This minus of this. So this will be what? 0. This is 30. And what will be this? 30. This will be minus of 20. And this will be 8. So you will get, after applying elementary row operation, you will get this augmented matrix. Now see, although there are 4 equations, but by applying elementary row operation, you have eliminated one equation because that is not required here. So all are 0. So what we will do, let's write this particular row as a last row. So next step is, let's write this as a last row. So this will remain first. So 1, minus 1, 1, 0. Then this is 0, 10, 25, 90. And then you have 0, 30, minus 20 and 9. This will be 0, 10, 25, 90 and this will be 80. So you have eliminated x1, 2. This will be 0. We have eliminated x1. Now second, this is the pivot element. Pivot row and pivot element. And we want to eliminate, because this is already 0. So we will eliminate this only. Let's eliminate. So how we will write? This is R3 minus 3 times of R2. R3 minus 3 times of R2. So next step. So this will be 1 minus 1, 1. This is 0, 0, 10, 25, 90. And then you have R3 minus of R3 minus 3 of R2. Let's check. R3 minus 3 of R2. What you will get? Ye 0 hoga. This is 0. And this will be minus 95. Minus of 80 minus of 270. Plus or minus? Minus 190. 190. 0, 0, 0. So this will be the situation. So just see, we have eliminated x2 and now you should focus on this. And from this equation, what you will get? This is minus 95 x3 is equal to minus 190. So that will give you x3 is equal to, this is x3 is equal to 2. Now we will see this equation. So that is given by 10x2 plus 25x3 is equal to 90. So what will be x2 here? Just solve. 40. So x2 will be 4. Just if you put x3 here, so this is 90 minus 50 by 10. So x2 is 4. x2 is 4. And from this equation, first equation is x1 minus x2 plus x3 is equal to 0. So x1 minus x2 is 4 plus x3 is 2. So what will be x1? x1 is also 2. Minus x1 is 2. x1 is also 2. So you are getting x1 2, x2 4, x3 2. So it means it has unique solution. You have 3 unknowns and we have uniquely calculated values of x1, x2, x3. So this particular system has unique solution. So now in this particular case, it has unique solution. So whenever this situation arises, that you can from one equation you will get one unknown, then by back substitution you will get the other unknowns. So in that case you can say it has unique solution. So normally in exam they will now not ask you what is value of x1, x2, x3, but they will ask you whether this particular linear system of equation has unique solution, no solution or infinitely many solution. So by using the elementary row operation you can check it. ठीक है? So write down. हो गया? Let's take another example. You should try. If you have x plus y minus z is equal to 9. 8y plus 6z is equal to minus 6. then you have minus 2x plus 4y minus 6z is equal to 40. Again, you have to check whether this system has unique solution or no solution or infinitely many solution. So you have to write the augmented matrix, write down the augmented matrix. Write down the augmented matrix first. So this augmented matrix is, this is 1, 1, minus 1, this is 9, 0, 8, 6, minus 6, and this is minus 2, 4, and minus 6, and this will be 40. So this is the pivot row and pivot element, and we want to eliminate this. So what will be next step? R3 plus 2R1. So use that condition. 1 is plus 1, minus 1 and 9, 0, 8, 6 and minus 6, and you have R3 plus 2R1. So this is 0, this will be 6, and this is minus 8, and this is 58. Next step is, this is the so in this case, what you will do? This is 1, 1, minus 1, 9, 0, 8, 6 and minus 6. So what you will do? So let's multiply it by 4R3, and then this will be 3 minus 3R2. So this will be 24, this will be 24. Subtract it. So this is 0. This is minus 32, and this is minus 18. So this will be minus of 50. What about this? 58 into 4 plus 18. I think this will be 240. That value is 240. Please check. 232 plus 18, so that will be 250. Now if you see this minus 50 into z, and that will be 250. So z is given by minus 5. Z is minus 5. And then you have 8y plus 6z is equal to minus 6. So 8y minus 30 is equal to minus 6. This will be plus 24. 8y is 24. So y is 3. And then from first equation, x plus y minus z is equal to 9. Y is 3 plus 5. X value will be, x is 1 here. X is 1 and y is 3, z is equal to minus 5. So again it has unique solution. It has unique solution. Okay. Now we will see next example. Next example is you have 3x1 plus 2x2 plus 2x2 plus 2x3 plus 2x3 minus 5x4, and that is 8. Then you have 0.6x1 plus 1.5x2 plus 1.5x3 minus 5.4x4, and that is 2.7. And then you have 1.2x1 minus 0.3x2 minus 0.3x3 plus 2.4x4, and that is 2.1. Now we have 3 equations and 4 unknowns. So in this case, 2 possibilities there, whether it has no solution or it has infinitely many solutions. So we will check for that. Write down the augmented matrix. This is 3, 2, 2, minus 5, 8, and this is 0.6, 1.5, 1.5 minus 5.4, 2.7, 1.2 minus 0.3 minus 0.3, 2.4, and this is 2.1. So this is the pivot row and pivot element, and we want to eliminate this. So this is 3, 2, 2 minus 5 and 8. So this will be R2 minus 0.2 R1, because this is 0.6. So multiply with 0.2. So what you will get? This is 0. This will be 0.4, 1.5 minus 1.1 here. This is also 1.1, and this will be multiply with 0.2. So this is 1, and this is minus 4.4. And what will be this value? 0.2 is 1.6. So 2.7 minus 1.6 is 1.1. And then you have R3 minus 0.4 R1. So this will be 1.2. So this is 0. This will be 0.8. So minus 0.3 minus 0.8. So that will be minus 1.1. This is also minus 1.1. And then 0.4 is plus 2.4. So that is 4.4. And what will be this value? 2.1 minus of 2.4. R3, this is 3.2. So minus, so that is minus 1.1. You will get this value. Minus 1.1. So again, now this is the pivot row. And we want to eliminate this. So next step is this is 3, 2, 2 minus 5, and this is 8. Then you have 0, 1.1, 1.1 minus 4.4, then this is 1.1, and then you have R3 plus R2. So that will be eliminated. This will be eliminated. So one row is eliminated. Now you will get two equations and there are four unknowns. So from this relation you will get one equation is 1.1 x1 plus 1.1 x2 minus 4.4. This is x2, this is x2, this is x3, and this is x4, and that is 1.1. Divide by 1.1, so x2 plus x3 minus 4x4 is equal to 1. So x2 is it correct? So what will be x2 from this equation? x2 is 1 minus x3 plus 4x4. You will get this equation. And from this equation, you have 3x1 plus 2x2 plus 2x3 minus 5x4 is equal to 8. So let's put the value of x2 here. So what you will get? 3x1 plus 2 minus 2x3 plus 8x4 minus of 5x4, that should be 8. So this you have 2 minus 2, this is the value of this 2 and plus 2x3 also. This 2x3 is there. So this is 2 minus 2x3 plus 8x4. You have plus 2x3 also. So this will cancel out. So this will give you 3x1 and minus of 5x4, and that should be 8 minus 6 is 8 minus 2 is 6. No, so this will be 3. So you will get plus 3x4 is equal to 8 minus 2 is 6. So x1 plus x4 is 2. So x1 will be 2 minus x4. So x1 is 2 minus of x4. So in this case, if let x3 and x4 are arbitrary, by taking any value of x3 and x4, you will get different values of x1 and x2. So you won't get unique solution. You will get infinite solution. So that's why this system has infinitely many solutions. So no need to calculate for it, because in exam they won't ask you the value of x1, x2, x3, but they will just ask you whether it has unique solution or infinitely many solution. So whenever you have this type of situation will arise, you can see you have two equations and four unknowns. So you will get infinitely many solutions. So by seeing the augmented matrix, you can check. Okay? Now we will see next case. So here you have 3x1 plus 2x2 plus x3 is equal to 3. You have 2x1 plus x2 plus x3, and that is 0. You have 6x1 plus 2x2 plus 4x3, and that is 6. Now let's check. Now write down the elementary augmented matrix and then check. So here we will write the augmented matrix, that is 3, 2 and 1. So this will be 3, this is 2, 1, 1 and 0. 6, 2, 4 and so we want to eliminate this. So let's apply elementary row operation. So this will be, this is, you can see this is R2 minus 2 by 3 R1 also. Because if you multiply 2 by 3, this becomes 0. This is 1 minus 4 by 3. So that is minus 1 by 3. And then 1 minus 2 by 3 is 1 minus 2 by 3 is 1 by 3. And this will be minus of 2. This will be minus of 2. And what about this? R3 minus 2 of R1. So this will be 0. And this will be 2 minus 4. So that is minus of 2. And this is 4 minus 2 is plus of 2. 6 minus 6 is 0. 6 minus 6 is 0. You want to eliminate it? That is also correct. No issue. You just eliminate this. So now you want, this is the pivot element. Let's eliminate. Eliminate it. You want this to be 0. So this will be 3, 2, 1, and this is 3. You have 0 minus 1 by 3, 1 by 3 minus 2, and this will be R3 minus 6 R2, because this becomes plus 2, this becomes minus 2. So what will happen? This is 0, this is 0, this is also 0, and this is 12. Now you have to focus on this condition. whenever this situation is arise, 0 is not equal to, whenever this condition arise in an augmented matrix, you will say that it has no solution. It has no solution. So you will encounter these three situations: when you have unique solution, infinitely many solution, or no solution. So just by seeing the augmented matrix, you can decide. Clear? So let's take another example here. So here 4y plus 3z is 8. Then you have 2x minus z is equal to 2 and 3x plus 2y is equal to 5. 4y plus 3z is 8, 2x minus z is 2, 3x plus 2y is equal to 5. Now you have to check whether it has unique solution, infinitely many solution, or no solution. So in this case, we will write the augmented matrix. So this will be 0, 4, 3, and this is 8. Then you have 2, 0, minus 1, 2. Then you have 3, 2, 0, and 5. Now, next step is we want this to be non-zero. So what we will do, let's shift it. So this is 2, 0, minus 1, 2, 0, minus 1, 2, and this will be 0, 4, 3, and 8. And then you have 3, 2, 0, and 5. No solution. Now, this is the pivot row, and eliminate zero here. So what will be next step? 2, 0, minus 1, and this is 2. This will be 0, 4, 3, and 8. And you should multiply here 2 times R3 minus 3 times of R1. So that will be 0. This will be 4. And this will be 0 plus 3. This will be 3. And this is 10 minus 6 is 4. Now next step, this is the pivot element. 2, 0, minus 1, and this will be 2. Then you have 0, 4, 3, and 8, and this will be R3 minus of 2R2. This is 0, 0, 0. This is R3 minus R2. Yes. So this will be, this is R3 minus R2. And this will be minus of 4. So again, you can see this condition. 0 is not equal to -4. So whenever this situation arises, we say that it has no solution. It has no solution. ठीक है? One last example. Equations are given as x plus y is equal to 1, y plus z is equal to 1, and x plus z is equal to. Let's check. You have to check existence and uniqueness of the solution. So again, write down the augmented matrix. So this will 1, 1, 0, and this will be 1. Now this is 0, 1, 1, 1, and this is 1, 0, 1, and so this will be the pivot row. One, 1, 0, 1. So this will remain same, 0, 1, 1, and this will be R3 minus R1. So this is 0, minus 1, 1, and 0. Now we will take this as a pivot row, and we want to eliminate this to be 0. So this is 1, 1, 0, 1, and this is 0, 1, 1. Now you have R3 plus R2. So this will give you 0, 0, 2, and 1. So in this particular situation, you will get unique solution, because this will give you z, this will give you y, and this will give you x. So just by seeing z is equal to half, so and so on. So you can calculate that value. So what is x, y, z? All are half values. So it means it has unique solution. This system of equation has unique solution. So whenever linear system of equations are given, you have to check whether that system has unique solution, infinitely many solution, or no solution. And just by seeing the augmented matrix after applying the elementary row operation, you can check. 3 situations will arise, and we have discussed all those 3 situations. Clear? So that is all about linear system of equations.